So good day to all. My name is Decaret Bacho, and we are the Group 3, and we will be discussing the continuation of the maneuvering boards. So converting true and relative bearings. Converting relative bearing to true is accomplished by using the following formula, which is true bearing equal to ship's heading plus relative bearing. For example, contact bears 270 degrees relative. Ship is on course 330 degrees true. What is the true bearing to the contact? So first, we will be using the formula. And next, true bearing is equal to 330 degrees plus 270 degrees. So the true bearing is equal to 600 degrees minus 360 degrees would result to a true bearing of 240 degrees true. So the maneuvering board. So it has a purpose to plot the position of a ship relative to the position of another ship. Its applications would include collision avoidance to get the CPAs, formation steaming, and station keeping, the RDVU intercept, the UNREPs, and getting the wind problems to get the desired wind. So the maneuvering board would be described as having 10 concentric circles, bearing lines radiating from the center, 5 scales provided, and nomogram provided. So a nomogram is a two-dimensional diagram designed to allow the approximate graphical computation of a mathematical function. So next, the relative plot. So it is defined as a polar representation of the successive positions of one or more moving objects with respect to a reference position. This reference position will normally be your own vessel. The bearings and ranges are taken from your radar. So the relative plot. So the maneuvering board would include E, the reference ships, which is placed in the center, M1 and M2, any maneuvering ship, the DRM, or the direction of relative motion, the MRM, measure of relative motion, the SRM, speed of relative motion, and the CPA, which is the closest point of approach. So the CPA, or the closest point of approach, is made up of three parts: the range or distance, the bearing, and the time.
Good day, I am Nikirit Kian Pibay, and today I'm going to tackle about in setting up of a move board or a maneuvering board. So, a maneuvering board is an aid to navigation, where it is a writing surface with a compass rose of polar coordinates around a central pre-printed on it, along with an adjacent linear scales, and on rare occasions, a time, speed, and distance nomogram. So, first, we must determine the scale. So it has two scale, the speed and distance. So the normal scale is 1:1. So this means that 1 mile on the board equates to 1 mile of distance between your vessel and the radar contact. So it is possible to use one scale for distance and another for speed. However, it is generally easier to use a single scale for all calculations for each contact. So this is a maneuvering board. So in both sides of the maneuvering board, there are two scales where we find the distance scale and speed scale. Second, plot yourself in the center of the move board. Then, plot your ship's speed and distance. For example, you are on a course of 050 degree true at a speed of 15 knots. So we plot it in the center line and use the speed scale to determine the speed and create a line, then straighten the line to the given course, which is the 050 degree true. Next is determining CPA. At 0800, a contact bears 280 degree true at a range of 16,000 yards. Number 1, plot M1. Points on the move board that correspond to the bearings and ranges of the contact. Note, use a 2:1 scale. So, we plot the M1 where it points the move board that corresponds to the bearings and ranges of the contact. So, The point M represents the location of the radar contact. Subsequent positions are designated as M1 or M2 or etc.
So at 0815 hours, same contact bears 300 degrees true at 10,000 yards. So find the CPA bearing, range, and time. So as the M1 is already been plotted, which has the bearing of 200 degrees true and range of 16,000 yards. So next is we have to plot the M2, which has the bearing of 300 degrees true and a range of 10,000 yards. So next is we have to find the DRM. So to find the DRM, we have to connect the M1 and the M2 with the ruler. And then move the ruler into the center of the maneuvering board. And there we can get the DRM. So at this case, we have the DRM of 0.73 degrees true. So next is we have to find the MRM. So to find the MRM, we have to measure the distance between the M1 and the M2 with the use of compass ruler. So in our case, we have a MRM of 7,500 yards.
Determining CPA. At 0800, contact bears 280 degrees true. A range of 16,000 yards. At 0815, the same contact bears 300 degrees true. At 10,000 yards, find CPA bearing, range, and time. So enter the monogram with 7,500 yards and 15 minutes. So in the scale or maneuvering board, you need to plot the 7,500 yards and 15 minutes. So elapsed time between the interval between the 0800 to 0815 to find the SRM. So we know that the interval between the 0800 to 0815 is 15, so we have the SRM of 15 knots. So we already solved the SRM. We need to know what is the CPA bearing. So the CPA bearing, we need to add or subtract 90 to from the DRM and to the CPA bearing. In this case, 90. So we need to subtract 90 from 73 degrees true. So subtract it. 0.73 degrees true minus 90 degrees true. Since we don't have a negative value, we need to go counter so that we need to do clockwise, counterclockwise, so that we can get the value, since the lowest value in the true is 0. So once we go back, minus 0.73 degrees true minus 0.90 degrees true, we can get 343 degrees true, and that is our CPA bearing. Another example of determining CPA. So at 0800, contact bears 280 degrees true at a range of 16,000 yards. At 0815, their same contact bears 300 degrees true at 10,000 yards. Find CPA bearing, range, and time. So first, we need to find the CPA range. So CPA range measures from the center of the maneuvering board to the CPA point to determine the CPA range. So as you can see in the maneuvering board, we plotted the 10,000 yards and the 16,000 yards, and the problem is we need to get the CPA range, since we know that CPA range is measured from the center of the maneuvering board to the CPA point. So as you can see in the illustration, from the CPA to from the center of the maneuvering board, we need to go to the CPA. So the distance between the maneuvering board and the CPA range is CPA, or the closest point approach, is what we call the CPA range. Now, we already solved the CPA range. We need to solve the CPA time. Measure the distance the CPA time measures the distance between M2 and the CPA point. This distance is 6,900 yards. Enter the monogram with 6,900 yards and SRM of 15 knots. So since we know that there is a distance between the M2 and CPA point, that's what we call the CPA time. So we have the 6,900 yards, which is given, and also a speed which is 15 knots. So we can use the formula of DST, or the distance, speed, and time, since we have already given the distance, which is 6,900 yards, and the SRM or the speed is 15 knots. So just divide 6,900 yards to 15 so we can get 14 minutes. That's all. Thank you.